All right, so we come around to this, that this experiment does not support the explanation because there's no significant difference between the heavy and the lighter stone. Um, the values for the heavy rock vary by more than 1/10 of a second, and same thing for the light rock, and then the average value is only 2/100ths of a second difference. So there's more uncertainty than there is difference between the two quantities. All right, so uncertainty can never be eliminated, but you can take a lot of data, and that helps you quantify exactly how uncertain something is. These histograms kind of give you an idea of that. You repeatedly do this experiment, and you get a range of times, and that kind of helps you center in on what the uncertainty in the time is. And there's some pretty advanced math that goes along with statistics to figure out the degrees of certainty. Basically, if you set this measurement error bar all the way from here to here, you have absolute 100% certainty, and then as you narrow it down, maybe this one is like 95% certainty that the measurement lies within this error bar, and the smaller it gets, the lower the percentage of certainty that your measurement, at least in this experiment, is within that. Now, overall, you do want to have the smallest uncertainty possible in your experiment. All right, so let's talk about logic. So how do you know a statement is true, and how is a scientific argument made? So the if-then structure will create a statement that can be true or false. So if you start off with this, if the Earth is round, by the way, this is going to be the structure of most hypotheses, then it should be possible for you to travel in the same direction and end up back at your starting place. Then that's verifiable. You can do an experiment to find out. All right, so you can try this yourself. Write out an if-then statement involving some aspect of science, and then you may not be able to share that with the group, but you can think about it. Okay, and then also we can talk about why do things happen. So those are cause and effect relationships. So one thing is done, and then something else reacts in. All right, so there are a lot of things in physics where you can explain them with a cause and effect relationship. Something changes, and that causes another change to impact. You can also give that a try. All right, so here's a statement of what science is, but it's a use of evidence to construct testable explanations, predictions of natural phenomena, as well as knowledge generated through the process. All right, so let's check this one out. You see an icicle hanging from a branch or roof, and notice the ice forms some ripples on the surface of the icicle. Which of the following is a valid way to test a hypothesis about these ripples? So would you do research? Would you look for information? Would you ask a teacher, or do an experiment? Valid way to test a hypothesis. That's it. You would do an experiment. All right, and let's see. Which of the following could be scientific evidence? Speedometer reads 57 miles per hour. Photograph shows And I think we can answer yes to more than one of these. So a photograph shows a Venus at specific position in the evening sky. Newspaper headline announces the discovery of a previously unknown fundamental particle. You notice that the temperature outside is 27 degrees Celsius, and a teacher tells you that the atomic mass of carbon is 12 grams per mole. All right, so the scientific evidence, these things. Simply being told about something is not always scientific evidence. Now, this one could be restated more of the idea of a scientific paper provides evidence, then yeah, that's probably scientific evidence. But as you may have noticed, sometimes when scientific evidence is disseminated by news sources, the scientific evidence sometimes gets the backseat to some sensational claim like eggs are good for you or eggs are bad for you, and you might be really confused unless you understand that the scientific paper may not be trying to figure out whether eggs are good or bad for you. It may be relating it to different health aspects, and sometimes those health aspects positively relate to something, and sometimes they negatively relate to something else. All right, so you're in chemistry class, the teacher tells you this, it's in the textbook. Well, there is some underlying scientific evidence, but just because the teacher tells you something isn't necessarily the core reason why that could be scientific evidence. So that's the key thing there, is you're being told this rather than given evidence to support it. Which, by the way, we do that a lot. This would be knowledge base that's come about from lots of scientific exploration. All right, so thanks for watching. That's the end of this video.